Alright, now this is the question 4 in deformation of solids. Okay, a 15-kilogram ball fastened to the end of a steel wire of unstretched length 0.5 meter is wheeled in a vertical circle with an angular velocity 2 revolution per second. 2 revolution per second at the bottom of the circle. Wow, it's a circle. The cross-section area of the wire is 0.02 centimeter square. Calculate the elongation of the wire when the ball is at the lowest point of the circle. Yeah. Now, Young modulus given for steel is, this is a steel wire. So the Young modulus for the steel given 2 exponent 11 Pascal. Okay, information given. Okay, first identify information given. You have the mass of ball. It's a steel wire with this Young modulus. Yeah, steel Young modulus is this one. Remember, the Young modulus depend only on the type of material. Our material is the steel. So this is the one. Okay. Unstretched length. Unstretched means the original length. Okay. So 0.5 meter is the original length, L0. We're in the vertical circle. So this is a circular motion. Okay. First I write down this is a circular motion. This is a circular motion. With angular velocity 2 revolution per second. So this is definitely the omega, but revolution per second is not the unit for omega. We must change to radian per second. Yeah, this is revolution per second. Revolution per second actually is revolution per second, RPS. RPS. Okay, revolution per second is RPS. But we must change to radian per second later on. At the bottom of the circle, okay, bottom means at the lowest point, okay. That means the ball has this omega 2 revolution per second when it is at the lowest point of the circle. Okay, at the lowest point of the circle, it has this angular velocity. Yeah, I mean the ball. The cross-section area of the wire is this. This is the area, cross-section area of the wire. Yeah, cross-section area. That means the cable, the wire, you know, the steel wire. This is the cross-section area. Yeah? The area. The wire, yeah? Cross-section area. The wire 0.02 centimeter square. So it's not SI unit. Must change to SI unit. Meter square. Calculate the elongation of the wire. That means I want to find E, elongation, at the lowest point. Okay, let's do one by one. First of all, we have the mass. We have the original length, 0.5. We have the omega, revolution per second. So revolution per second means revolution per second, RPS. So to change to radian per second, we just, what we do? We just multiply by 2 pi. Remember that? To change to radian per second, multiply by 2 pi, you will get 4 pi. 4 pi radian per second. That's the omega. That's the omega at the lowest point, you know, of the circle. Okay, multiply 2 pi, get 4 pi radian per second. Now, I have the cross-section area for the wire also. Centimeter square, change to meter square. Centi at the power of 2. Centi is negative 2, isn't it? Centi is negative 2. And at the power of 2 become negative 4. Many students make mistake. Yeah, this centi, because under the power of 2, the centi is negative 2. But under the square, it becomes negative 4. Okay, remember that. And change to SI unit, meter square already. Yeah, good. Now I got the cross-section area in SI unit. The Young modulus is this one in Pascal or Newton meter per meter square. Okay, so what should I do now? I already identified this is a circular motion. It's a vertical circular motion somewhere. Yeah? Circular motion. Okay, let's talk about circular motion. When the object is at the bottom of the circle, okay, at the bottom of the circle, this is the free body diagram. Always draw a free body diagram. Okay, at the lowest point, the center of circle is at the top. So first of all, draw the free body diagram. Identify all the forces acting on the ball. So actually our concentration is on the wire, this wire, pulling on the ball. Actually our focus is on the wire. We want to find what is the force acting in the wire. We know that the force acting in the wire is the tension. So actually our focus is only on this wire, you know, not on the ball. The ball is not our concern. Our concern is actually the steel wire. Yeah, this is the steel wire right there. This is the steel wire pulling on the ball. So actually our focus is on this steel wire. We need to find the tension that exists in the steel wire. We must find the tension, then only we can find the elongation, yeah, for the steel wire. So our focus is the wire, not on the ball. So we want to find what is the force acting in the wire. The force acting in the wire, of course, is the tension. But to find this tension, we need to apply the knowledge of circular motion and Newton's second law. Okay. So back to chapter circular motion. Okay, chapter circular motion. So at the bottom of the circle, so the force in the steel wire is the tension. Tension is pulling up. Yeah. Tension only pull on object, never pushes. Yeah. Pull on objects. And mg go below. And because the center is above the ball, so our centripetal acceleration. Remember, for circular motion, it has centripetal acceleration towards the center of circle. So because our center is at the top, so our centripetal acceleration is to the top, going upward. And then go back to the sign convention. For Newton's second law, follow acceleration is positive, isn't it? Positive is follow acceleration. Negative means opposite acceleration. In our case now, our acceleration is centripetal acceleration. So follow centripetal acceleration is positive. Opposite centripetal acceleration is negative. So this tension is positive because follow acceleration. Mg is negative. So now we write. Yeah? According to the Newton's second law, total force equal to MAC. Now our acceleration now is the special one, centripetal acceleration. Okay. In fact, this resultant force is the centripetal force. Fc equal to MAC. Yeah. Centripetal force is the resultant force on the ball. Okay. So now the tension is positive, mg is negative. So just write there. Tension is positive, mg is negative. So equal to, so E minus mg become the centripetal force, become the resultant force, centripetal force. T minus mg equal to MAC, and then remember our AC for circular motion we can change to, we have omega here, isn't it? We have omega. Actually, our centripetal acceleration has several formula: v squared over r, r omega square, and also v omega. But because since we have omega, we don't use the other two. We use r omega square. And we use r omega square. So AC can substitute with r omega square. Yeah, we don't have v, we have omega, so we use r omega square. So our AC can substitute with r omega square. So become mr omega square. This is chapter 6, circular motion. So we can find our tension in our steel cable, steel wire. So mg go to the other side, become positive, plus mr omega square. And then factorize the mass, g plus r omega square. And g is 9.81 plus, plus the r is what? Do we have r? Our r is actually the length of the steel wire. This is the length of the steel wire become the radius, yeah, because the whole wire is making the circle, becoming the radius of the circle, the whole length of the wire. So the length of the wire is the radius of the circle, 0.5. So 0.5 and omega is 4 pi. I got 4 pi just now. 4 pi square. Don't forget the square. R omega square. Mass, do I have the mass? Do I have the mass? Yes, 15 kilogram. Yeah, I have the mass. I forget to substitute the mass. Yeah, this mass is 15 kilogram. So just substitute 15 there. 15 there. So what do I get? So I get the answer after calculate. I get 1331.503 Newton. That's the tension in the wire. Very easy. Once we have the tension in the wire, we can find the stress in the wire. When we have the stress in the wire, you can find the strain in the wire. Strain in the wire, then we can find the elongation of the wire. Finally. Okay? And that's the whole picture. Now, we have the tension, we can find the stress. The stress in the steel wire, we know that the force in the wire is the tension. Okay? Force in the wire is the tension. So, force in the wire is the tension. I got the tension already just now. Tension. Area is, I already got in SI unit, area, meter square. So, substitute everything. Substitute everything. Tension is 1331.503. Cross-section area. Cross-section area is 0.02 exponent negative 4. Already in SI unit. So my stress is 6.6575 exponent 8 Pascal. Yeah, that's my stress of the steel wire. The stress in this steel wire because of the tension. Okay, so I got the stress already. I also have the Young modulus of the steel. I can find the strain. See, step by step. 2 exponent 11. So just substitute 2 exponent 11 Pascal. And then stress is 6.6575 exponent 8 Pascal. Okay, 6.6575 exponent 8 Pascal. So I got the strain. My strain is, this the Young modulus is Pascal. Stress also Pascal. So when cut off Pascal with Pascal, strain has no unit. Strain has no unit. So, okay. So calculate, I get what? What do I get? What do I get? Come on. My strain is 3.32. Sorry again. 3.3288 exponent negative 3. This is my strain. No unit because Pascal with Pascal. Pascal with Pascal. So this one has no unit. Okay, I got my strain. Once I got my strain, I can find the elongation of the wire. You have the strain means it has elongation. Okay, put my strain there. 3.3288 exponent negative 3. And then what is my original length? Original length is 0.5. 0.5. So just put my 0.5 there. Just put my 0.5 there. I can find my elongation. which is the answer? 1.66 exponent negative 3 meter. Or we know that exponent negative 3 is milli, isn't it? Milli. 1.66 exponent negative 3 is milli. 1.66 millimeter is the elongation. Is that correct? 1.66 millimeter. That's correct. Okay, that's the elongation. Okay. So very simple, isn't it? So what you have to do is you always identify what situation is this. This is a circular motion. Circular motion. You do the Newton's second law. Find out the tension in the wire. Once you have the tension, you can find the stress. Once you find the stress, you can find the strain. You can find the elongation. Okay. I think the hard part is over here. Yeah, you must understand the situation. So always the force in the wire is always the tension. Okay, force in the wire is always the tension, and this tension, we have these things. It has centripetal acceleration. So go back to chapter 6. Find out how to find the tension in the wire, applying the centripetal acceleration, centripetal force. Okay. The chapter 6 circular motion knowledge. And remember, the omega must always change to radian per second. Don't maintain as other unit like revolution per second, revolution per minute. You must change to radian per second. Okay. If the question gives you omega, then the AC you use r omega square. If the question gives you linear velocity v, then you use v square over r. Give you omega, then you use r omega square. So all this depend on the situation or what information the question give you. Give you v, you use v square over r. Give you omega, you use r omega square. Yeah. So this is how we do it. Okay. See you in the next questions. Bye.